This is problem number 9 of the second exam that you had. So this is your second test, and the problem here is to evaluate the integral of 2x plus 3 over the square root of 9 minus x squared. Well, the first thing you should always check is look in the denominator, look under the square root sign, and see if you see the derivative of what's under the square root sign up there on the top. So let's look at this. So if you take the derivative of 9 minus x squared, you actually get, so let's do that and see what we get. So we take the derivative of this, derivative of 9 is 0, derivative of negative 8x is negative x, and derivative of x squared is negative 2x. Well, we don't have that up there, so a u substitution isn't going to work. So now that a u substitution isn't going to work, we're not going to do that. What we're going to actually do is we're going to go and because we have this square root over here, we think of trig substitutions. So let's see what kind of trig substitution we can get. All right, so you've got the square root. You want to do a trig substitution. So what you're going to do is you're going to go and think, okay, can we complete the square? Because in trig substitution, in all these trig functions, we have these square functions. So let's go and complete the square over here. So let's see. So we take this 9 minus 8x minus x squared, and we write this as 9. Let me bring the negative out. 8x plus x squared. Now that's not the form that we're used to seeing, so let's rewrite it again. 9 minus x squared plus 8x. So what do we do now? We take this and we write as 9 minus, now open brackets because you want to make sure that you're multiplying the negative in at the end. You take this 8, you divide it by 2, you get 4, so you get x plus 4 squared. And so this gives you the x squared plus 8x. You're going to have an extra 16, so subtract 16 here. Okay? And go back, and you get 9 minus x plus 4 squared. This negative on the outside times this negative on the inside gives you plus 16. So we actually get 9 plus 16, which is 25, minus x plus 4 squared. All right, so let's go back over there and substitute this in. So we get the integral of 2x plus 3 over the square root of 25 minus x plus 4 squared dx. Okay, so now let's do a u substitution. So what's under what we have over here is going to be our u. So let's let u be equal to x minus 4. So therefore du is equal to dx. Okay, so we've got du is equal to dx. So let's go back. We've got to substitute for everything. So we need to solve for x over here. So we get that x is equal to u plus 4. So what did I do over here? I just added 4 to both sides. So let's go back over here and substitute. So we get the integral of 2 times u plus 4 plus 3 all over the square root of 25 minus u squared du. Okay, let's multiply it out. Get the integral of 2u plus 2 times 4 is 8 plus 3 over the square root of 25 minus u squared du. So we get the integral of 2u over the square root of 25 minus u squared plus du plus the integral of 8 plus 3 is 11 over square root of 25 minus u squared du. Okay, and this one you do with a u sub, and this other one you just recognize that this is your sine inverse function. So I'm going to leave the rest of this for you to do because I don't think I can get more than this on this recording.